All right, let's look at the theorem number 2, postulate of Pasch. All right, it says that A, B, and C are distinct and non-collinear points. All right, we got that so that we can form a triangle. If A, B, C are not on the line L, and line L meets open segment AB at some point D, right? Then we know that the L has to meet either open segment AC at some point E or open segment BC at some point F, right? So I'm going to just draw a line line here, line L. It's going through D. So this is going to be our line L, right? All right, let's look at this. So since these are all givens, A, B, C are distinct and collinear, right? And A, B, C are not on the line. And there is a point D such that D is between A and B. So that's the same thing as L meets, L meets open segment AB at D, right? So those are just givens. All right, and number 4, by lemma, since D is on the borderline and there's a betweenness condition ADB, so A and B has to be on the opposite side. So I'm going to just name it. So on the A side, I'm going to call it H1. On the B side, I'm going to call it H2. So you can, notation is you can say half plane A side of line L, or you can write H2 as a B side of line L, right? So we have that. So we can say A is in, say, H1, and also B is in H2, right? And we know that we can say that because of the lemma saying that A and B are on opposite sides. So I'm just going to say lemma. Right? Then number 5. Alright, so we can consider a couple different cases. We don't know exactly where C is. We know that the C is not going to be on the borderline L. So C is going to be either H1 or H2. Alright, so the way I drew it, C is actually in H2. So I'm going to do the case 1 is B is in H2. Or B could be in H1 too. So at H1. So if I drew line differently, say like this, right? So C could be in. So I'm gonna call it L1, and this is gonna be L2, right? So C could be on H1. So on the A side. So this is all possible cases. All cases. Right? Then 6. Right? So why not assume the first case? So let's look at pick on the first case. Assume that the B is in H2. Right? So this is our case 1. Right? So we're looking at this case here. C is in H2. Right? If that's the case, we know that the A and C are opposite side, so we can use axiom H1 part 3 7, saying that therefore we know that there exists some point. Let's see, I'm gonna call this point right here. Let's see, I'm gonna use this. So this point right here. Right, so since A and C are on the opposite side of the line, so we know that there's going to be a point E on the line L, such that E is between A and C, right? And which is the same thing as L meets open segment AC at E. Right, so this is the first case, and which is what we wanted, and so we got this one right there, and we can assume the other case. Assume that the B happens to be in H1, right? So which is this case? So A and C are on the same side, but the B and C are on the opposite side. So this is our case 2. Right, but we can make the same kind of conclusion. Since B and C are on the opposite side, we can use H1, line number part 3. There exists some point F on the line L, such that F is between B and C. Oops. Right, B and C. All right, so this will tell you that L meet open segment BC at F. All right, so we got 2 cases. So we just say number 10. Right, therefore L will meet L meets either. Right, open segment AC at E, or BC at F. So this comes from line 7 and line 9. All right, that's it. I hope that this was clear.